Hello viewers, welcome to Mobilemaths with Gamtry. So today I want us to look at paper 1, November 2021. So we want to get ready for our November examinations. The first question is saying express 30.098 correct to the nearest tenth. Okay, so what happens is this: when we have 30.098 like that, these are units and these are tenths, okay, and these are hundreds. Okay, so what you do, you go to your hundreds there and check if it is a number which is 5 and greater. When it is 5 and greater, then you change 0 to 1. So our answer will be 30.1. This is a 10th value there, okay, or 10th term. That's how we answer that one. Then correct to 4 significant figures. We have got 30.098 like that. To 4 significant figures is this one. We are saying this is 1 significant figure, 2, 3, and 4. So we now check the number that is following this one. Is it a 5 and a greater? Is it 5 and above? If it's 5 and above, you change 9 there. If it is less, then you leave it like that. Okay, so let's answer this one first. So it's 8, so it's greater than 5. So we are changing 9 to 10. So we now write 30.10. This is 4 significant figures. The 0 should be included because there are 4 digits, 4 figures, 1, 2, 3, and 4. If this 8 was below, let's say it was 4 and 3, 0.094 like that, you were going to write, because it's less than 5 there, you have your answer as 30.09 like that. Okay, then in standard form now we have got 30.0098. In standard form we don't have a which is greater than 9. Our a is 1 to 9. Then so we write our standard form as a times 10 to the power of n. N is a positive or a negative number. So because I'm moving from here going this direction, it is going to be a positive number. So I'll move 1 point. So my n is going to be 1. So my a is going to be 3. So I'll have 3.00098 times 10 to the power of 1. We write everything. You don't write 3 and leave this. No, you write it everything like that. Let's move on. Express 4 and 2/3 as a recurring decimal. Okay, so as a recurring decimal, the easiest way is to write it as an improper fraction. Here it is a mixed fraction there. So as an improper fraction, you multiply. So it's like 4 and 2/3 like that. You multiply there and you add at the top. So it will be 4 times 3. That will be a 12 plus a 2. That will be a 14/3 like that. Okay. Or else you can leave it like that. Let me just do this way and then I'll do the other one. So I'll say 3 into this one. That's a 4, comma, that's remainder 2. 3 into 20, that's a 6. 3 into 20 again, remainder 2, 6, 6, 6, 6, 6. So we are getting 4.66666 going on. 6 is recurring, it's repeating itself. So you can simply write 4.6 to the, and you put a dot there. Others can write 4.6 in the bar there. It's one and the same thing. Okay, so the other point that I wanted to say was this. Because it's a 4 and 2/3 like that, 4 is already a whole number. The decimal part is coming from this. So you can as well say 3 into 2, that's a 0. That's a 0 point there. Then I'll have 3 into 20, that's a 6. Into 20 again, 6, 6, 6. So you have 6 whole number plus 0.4 plus 0.6666, you get your 4.6666 that I was talking about. So that's another way of doing it, and you write your 4.6 like that. Okay. Now we have this, find the value of that. Others will use bomb dust. Let's just use, it's one and the same thing anyway. Bomb dust, board mass. Okay, so before operating divide and multiply, before operating multiply and divide, okay, it's fine. Let's answer it. 10 minus 10 divided by 2 plus 2 times 2 there. Me, I'll take it like this. 10, I'll write 10 minus, then this I'll take it like that. This I'll take it like that. 10 divided by 2, that's a 5, plus 2 times 2 there, that's a 4. I've done the multiplication and the division at once. Okay, so I'll get 10 minus 5, that's a 5 there. So I have 5 plus a 4, I'll get myself a 9 as my answer. So I've divided and I've multiplied. The order is anyhow. Either you multiply first or divide or multiply. But I think it should be easy for you to use brackets like what I've just done here. Let's go on to this one. This one is saying write down the next term in the sequence. Okay, so if you see, we have got 2, 3, 5, 8, 12. We want the next term. The difference from 2 to 3, that's a 1. 3 to 5, that's a 2. 5 to that one, 8, that's a 3. Difference from 8 to 12, that's a 4. So it means we are moving 1, 2, 3, 4. So I can also say here 5. So 5 plus 12 there, I'm going to get a 17. So that's my answer there. Okay, now let's look at question number 3b. We are asked to simplify 20 minus 8 divided by 20 plus 8. So in this scenario, and we want to leave the answer in its simplest form as a fraction. So in this scenario, you can first of all deal with 20 minus 8. If I say 20 minus 8, I'm going to get, that's a 12 there, over 20 plus 8 there, I'm getting a 28. I can divide 12 by 4 here, I'll get a 3, over 4 into 28, that's a 7. I cannot further simplify this fraction, so this becomes the simplest form of that expression there. Let's move on to the next question. List the prime numbers that are between 14 and 20. Okay. So you find out from 14, the prime numbers that we have are, we've got 17. Basically, actually, on this question, you have to understand what is a prime number. A prime number is a number that can be divided by 1 and itself. Okay, so the number that I have between 14 and 20, I've got 17. I also have 19. If you try to find a number that can go into 17, you only get 17 and 1. The same applies to 19 there. It's also 1 and 19. So these are the two prime numbers that are between 14 and 20. Okay. Then the second question is asking us write the number, that number in words. I don't want to say the number because the moment I say it is in words. So this number is basically 8. It's 800. It's 800. 801. 801. Sorry, it's 801,000 there, not end here. If I put end here, it becomes wrong at the end. So let me just say 801,000 and 8 and 8. Okay, like that. So this is basically 800. 1008 there. Okay, because you find out here we have got 1,000 there, 3 zeros there, and an 8, which is this one. Then the 801 is covered on that there. Okay, so basically that's how you write that in words. Let's move on to the next question. Express 6.65 hours in hours and minutes. What I can do, the 6 point, I will take this as hours. So this is basically, for me, these are the hours. Now I want to find the minutes. The minutes are on the 0.65 there. These are the minutes, but we don't have minutes like this. So what I'm going to do, I have to convert, these minutes are written in terms of over 100. Okay, so it's like I'm saying 65 is to 100 in terms of 100. Then I'm saying x is to 60 minutes now. Okay, so I want to convert it back to minutes. So it's going to be a less. You see, these numbers there, 100 is more than 60, so it's going to be less here. So when it's less, I'll say 60 over 100 times 65. So these zeros cancels there. 10 into 65, that's 6.5. So I have 6 times 6.5, which is giving me 39 minutes. So basically my answer there is going to be 6 hours and 39 minutes. 39 minutes. Okay, that is the answer there. Let's move on. List first three values of x such that 1. Okay, for me it is best to draw a line graph for this one. So I can have my line there from 1, 2, 3, and 4 there. Okay, like that. So we are starting from 1, 3, and 4. So because of this, it means you are also including, so it will be like this to 4 there. So shaded here, shaded also here. So the answers are lying from 1 to 4. So the first 3 are going to be 1, 2, and 3. Okay, so the answer will be 1, 2, and 3. Express 270 as a product of its prime factors in index form. We must highlight the index form and also prime factors. So what you do long division of 270 there and use your prime numbers. So I can have 2 there, that will be 1, 2 into 7, that's a 3, remainder 1, 5 there. Okay, then I have a 3 here, 3 into 13, that's a 4, remainder 1 into 15, that's a 5 there. 3 again goes there, 1, remainder 1, that's a 5. Again a 3 there, that's a 5. So I can have lastly 5 there, 1. So at the end of the day, I have got 270 is equal to 2 times 3 times 3 times 3 times 5. But these are the product of the prime factors, but not in index form. In index form, I will now write how many 2's do I have? I have 1. So I say to the power of 1 times how many 3's do I have? I've got 3 3's there. So it's going to be 3 to the power of 3. Then times 5, I've got how many 5's? That's 1. So this is the index form of 270 in its product of its prime factors. Okay, now we have got this bearing. They are saying if the bearing of P from Q is 0, 54, so basically it's 54 degrees there. So we are saying P from Q. So I can start with my Q here. Let me draw my Q. Okay, so this is my Q. And I'm saying from Q to P, it's going to be So this will be my P here. It's going to be this angle there. This is my north, and at this point this is also my north. This angle here is 54 degrees, 054 degrees. Okay, so that's what it means, because you'll be viewing P, you'll be viewing we are saying the bearing of P from Q, so you'll be viewing P from this point here. So the angle is going to be this one. Okay, fine. Now let's answer the question. What is it asking? Find the bearing of Q from P. Now we are at P and we want to find the bearing of Q. So what happens here is this. You are now moving from your north going to that point again, like that. So you have to take note that this is a Z angle here. Okay, so this angle is equal to that angle. So it is going also to be 54 degrees here. Then we have an addition of this 180 degrees. So at the end of the day, I've got 180 degrees plus 54 degrees. This is going to give me 234 degrees. So the whole angle that is going from north to the bearing of Q there is basically 234 degrees. So that's how we answer that question. Now we have another question. Calculate the number of sides of a regular polygon with interior angles of 162. So basically, when we have a regular polygon, let me just have an example here. Okay, so what it means here is this. This is a little bit exaggerated, but anyway, let's take it. I have 162 degrees here. I've got also 162 degrees here, and going on and on and on. I don't know how many sides. So that's the one question we want to find the number of sides. The easiest way to do is this. You can extend this or you can extend that, and you find the exterior angles there. So you find out the exterior angle. This is a straight line. So it's going to be 180 degrees minus 162 degrees. If you do this, you get yourself 18 degrees. So basically, this angle here is 18 degrees. And we know that when we are dealing with polygons, some of exterior angles, these exterior angles, add up to 360 degrees. So for me to now find the number of sides, I can say that total 360 degrees divided by the angle that I found for one side. So it's going to be like divided by 18 degrees there. So if I divide there, I'm going to get here 20. So I've got 20 sides. Okay, let's move on. Now we have this expression there, and we want to express as a single fraction in its simplest form. So for us to deal with this one, first of all, we can identify this is a perfect square, so we can rewrite it as 1 over x minus 1 and x plus 1, like that. Then we are saying minus 1 over 1 plus x, like that. Okay, then we can now simplify. Okay, so simplifying on this one, you find out that okay, so here you find out that this x plus 1 is the same as this x plus 1 there. So I can now have a common denominator of x plus 1 and x minus 1, like that. Okay, then now I can multiply this. I can divide this common denominator into this one, and I find, what do I get? You find out in this case it's going to be 1 minus, then for the second one it's going to be 1 by x minus 1, like that. Okay, so simplifying now, let's remove the brackets now. Okay, removing the brackets, I'm going to get 1 minus 1x minus, now it's now a plus a 1, all over x plus 1, x minus 1, like that. Okay, so here I've got a 1 here and a 1, so these are going to give me a 2 there. So I can have at the end of the day, this is equal to a 2 minus an x over x plus 1 and x minus 1, like that. Okay, so this is the final answer that we can simplify our expression to the simplest form of that. Okay, so that's our final answer then. Let's move on to the next question. Write down the largest 4-digit number in base 5. So here, basically, the largest number that we can have of any base is its base minus 1. We cannot have 5 because that's the base. So we have 4, 4, 4, 4. These are the 4 digits. 1, 2, 3, 4 digits. Okay. So, and we say base 5 there. Okay. Like that. Let's move on to the next question. Convert 118 to base 7. So when we have such a question like this, we have to first of all go to base 10, then we go to base 7. So to go to base 10, we are saying we've got 1, 1, 1, 8. So we say 8 to the power of 0, 8 to the power of 1, 8 to the power of 2. We raise the bases there like that. Then we say 1 times 8 to the power of 2 plus 1 times 8 to the power of 1, then plus 1 times 8 to the power of 0, like that. So this is going to be equal to, if we add this, is going to be equal to 8 squared, that's 64, plus 1 times 8, that's 8, plus 8 to the power of 0, that's the 1 there. So we are getting here at the end of the day a 1. Okay, so I can get here 64 plus 8 plus 1, that's 73, base 10. Now we want to go to base 7. I'm going to do my long division. So my long division is going to be 73 base 10 divided by the base that we want to go to, that's base 7. So I'm going to say 7 into 7, that's 1, 0, remainder 3. 7 there again, that's 1, remainder 3 again. Then 7 into 1, that's a 0, remainder a 1. Then we take our answer from the bottom going up. So the number is going to be equal to 133 base 7, like that. Okay, let's move on to the next question. Factorize completely this expression. So you find out they have removed a common factor here already for us. So we can now also find a common factor for the next two group there. Okay, for the next group. So basically we have x squared bracket y plus 1, like that. Then for this one, I have a common factor of minus 1 there. Then I'll remain with y plus 1, like that. Now I have got two similar groups there. So I can say this y plus 1, and now I take these ones together. They'll give me x squared minus 1, like that. Then you find out this is not the final answer for our question. This is a perfect square, and we can write it as y plus 1. This perfect square is x minus 1 and x plus 1, like that. So now we have completely factorized our question. Let's move on. We have log 64 base form. So what I can say, I can equate this to x, okay, because we want to find the value there of x. So when I do this, I can say my base, I can raise my base to x there is equal to my number, which is 64. And I can think of a number 64, I can raise 4 to base 4 to the power of 3. It will give me, this is the same as 4 times 4 times 4. So that's 4 to the power of 3. So I can rewrite this and say 4 to the power of x is equals to 4 to the power of 3, like that. Then when I get to this point, you find out I have same bases there. So I can equate these. So my x is going to be equal to a 3. So the value of log 4, log 64 base 4 there is equal to a 3. Okay, let's move on. Now we've got another log there. Okay, so they are dividing. I was thinking of subtracting, but it will be a long way. So the easiest way that I can do is I can think of a number that I can rewrite 8 there and also 16. So this is going to be equal to log, if I say 2 to the power of 3, that will be like 2 times 2 times 2, I get an 8. Okay, that's fine. Over log, if I also say 2 to the power of now 4, so it's like 2 times 2 times 2 times 2, I get a 16. Okay, so this is still the same expression. I have done nothing there. Now I'll remove the powers. The power when we are dealing with logarithms becomes like 3 log 2 like that over 4 log 2 like that. And when we get to this point, you find out log 2 and log 2, they are similar, so we can cancel them together and we'll get a 3 over 4 as our answer there. Okay, let's move on. Now we have a simultaneous equation. For this one, I want to simplify my life. I want to make the x's there equal, these x's there. These ones, I want to make them equal, so I want to have them as 4's there. So I can multiply this one as by 2 and this one by 1. Okay, so what do I get when I do that? I'll get 4x plus y is equal to a 4, like that. Okay, then for the next one, it will remain the same, but I have to arrange so that I have the x's there and the y's there. So let me do that. It's going to be minus 4x plus a 5y is equal to 13, like that. Now we have reached this point. At this point, I have to find, am I going to add to get a 0 there, or am I going to subtract? So you find out if I add, I'll have 4 minus 4. It's like 4 plus minus 4 there will give me 4 minus 4, which is equal to a 0. So that will work for me. So I'll have a 0 here. Then plus y plus 5y there, I'm going to get, oh sorry, I forgot to multiply y by 2. So this is a 2 here, and this is an 8. These are some of the silly mistakes that we make in the exams. This is 8 there. Okay, so it's going to be 2y plus 5y, that's a 7y, is equal to 8 plus 13, that's a 21 there. Okay, let's move on. So now 7y is equals to 21. I can divide here by 7, here by 7. So my y is equal to 7 into 21, that's 3. So my y is 3. Okay, let's find the value of x. I can use the first equation there. 2x plus y is equal to 4. Substituting y as 3, I'll have 2x plus 3 is equal to a 4. And taking this 3, that side, it becomes a minus. So I'll have 2x is equals to 4 minus 3. Okay, so 2x is equal to a 1. I will divide by 2 both sides to get my x. This side, they cancel off each other, so it's going to be x is equals to 1/2. So these are the values of x and y there. Okay, you get yourself 3 marks. Let's go on to the next question. The next question wants us to find highest common factor of those two expressions. Okay, so you find out for the first expression, I can say the first expression that I'm going to rewrite it in terms of prime factors, like 10 there. It's a product of 2 times 5. Then we have got an x plus 1, like that. Then for the second one, that's a 2 by 2 by 2. Then we have got x plus 1 multiplying x plus 1 there because it's squared here. Okay, so we have just rewritten that. Now to get our highest common factor. Highest common factor is a factor that will go into this expression and we'll also go into that expression. Okay, so that's what we want to find. You find out for the first one, I have a 2 here is common. Okay, then I also have this is also common. So these are the factors that I have. So you find out my highest common factor is 2 and x plus 1 there, like that. So this is the final answer there. Let's move on to the next question. Oh, the next question is asking us to find the lowest common multiple. Okay, so I'm going to rewrite again those. We have got 2 times 5 by x plus 1 there. And the other one was 2 by 2 by 2, x plus 1 and x plus 1, like that. So lowest common multiple is a number that we want to, when we have that number, it should be divided by this one, and it goes there without any remainders. Then also this one will also be able to go into that number. An example that I can give is this. Let's say if I've got 2 and 5. The lowest common multiple that I can think of is a 10. I'm not showing how I found that, but I want to express my point of my lowest common multiple. 2 can go into 10 and give me 5 without remainder. 5 can also go into 10 without also giving remainders. That's the idea of a lowest common multiple there. Okay, so looking at our question now, to find the lowest common multiple there, I will take each and every term. So I'm going to take a 2 here. So when I take this 2, I can write 2 times. It's the same as 2 there. I still have 2 more 2s, so I'm going to multiply 2 here, another 2 here. So I've got 2 3s there. Okay, then I have another 5, so I can also multiply here by a 5. We are done. Then I'm taking this bracket, which is similar to that bracket, so I can say x plus 1, like that. I'm left with another bracket, this one, so I can also say x plus 1, like that. So at the end of the day, if I multiply this, I'm getting a 40, and I have my x plus 1, x plus 1, like that. If you want, you can leave it like that. If you want, you can say 40 x plus 1 squared. All the numbers are going to go into that, because this one, the first one, is 10 x plus 1. It will go into this one, and we can have x. We can have 4 remainder x plus 1, 4 and x plus 1. Then the other one was 8 and x plus 1 squared. It will go there, and we get a 40 divided by 8 there, our 5 there. Okay, let's move on. On this question, we are asked to find, we've got a triangle. So let me just draw the triangle. So this is my triangle. It has got a 5 centimeter, an 8 centimeter, and a 12 centimeter, like that. Okay. Then they said find the cosine of the smallest angle as a common fraction in its simplest form. The smallest angle. Okay. So the smallest angle that I can think of is the number which has got the smallest side here. That's the angle there. Basically, that's number 1. Number 2, how do I find it? We are going to use the cosine rule, which says cos A is equal to B squared plus C squared minus A squared over 2BC, like that. So in my case, I can say this is my cos A, this is my A, like that. So this is my cos A, and this is my A side. Okay, this I can say this is my B, this is my C. So this is my small letter C, my small letter B there. Then we can substitute. Let's substitute. So I'm going to have cos A is equal to my B is 8 squared plus my C is 12 squared minus 5 squared there, all over 2 by B, that's 8, times our C, 12 there. Okay, so I'm going to get here, when I do this, I'm going to get, if I multiply here, I'm going to get 8 squared, that's 64, plus 144 minus 25 over 2 times 8 times 12. I'll get myself, let me just multiply this one. 2 times 8 times 12. I'm getting 192 there. Okay. Then adding 64 plus 164 plus 144, that's 208, minus 25, I'm getting 183 there over 192. Okay, so dividing this, I'll get myself a 0.953 there. Okay, so cos A is equal to that. But we want the angle A. So we can say A is equal to arc cos of 0.9530 there. So it's going to be 17.6 degrees. That's our answer there. Okay, let's move on to the next question. Okay, the next question is saying solve this equation. So we have got 5 to the power of x is equal to 125. I can also rewrite it in terms of 5 to the power of, so it's going to be 5 to the power of 3, because 5 times 5 times 5 gives me 125 there. Okay, so when I have this, there are same bases there, so I can equate the powers and I can say x is equals to a 3. Okay, I've solved the equation. Let's move on to the next question. Okay, the next question is saying simplify this expression. Okay, so basically when I have such an expression, I can divide. I'm thinking of dividing 98 here and also dividing 32 there by 2. I just want to simplify it. So if I said 98 divided by 2 over 32 divided by 2, I'm going to get myself, when I do that, I will get 49 here over a 16, okay, to the power of minus half. Now I want to deal with the minus half there. Basically, when we have a minus, it means it's 1 over something. So it is basically 1 over, it's 1 over the whole thing, 49 over 16 to the power of half, like that. And when we get to this point, then you can as well invert and say it's now at the end of the day 16 over 49, then you say to this power of half, like that. It's one and the same thing. Okay, how do we say it's one and the same thing? Let me just show you. We are saying 1 divided by this whole thing there. So the whole thing, I can say it's 1 divided by 49 over 16 to the power of half there. Then to remove this division sign there, we invert and we say 1 times 16 over 49 there to the power of half. That's why I just said it just changes like that. Okay, now let's simplify. To the power of half is the same as square root. So we can say this is equals to square root of 16 over square root of 49. If the whole thing is like that, we can as well, it's the same as 16 over 49 square root. And I can rewrite this like that. Okay, let's finish off. Square root of 16, that's a 4, over square root of 49, that's a 7. So because of the square root, you can say your answer is plus or minus 4 over a 7 there. Okay, let's move on to the next question. Given that we have got our x is in the range of -2 to 5 and our y is that. Find the greatest possible value of y squared minus x squared. Okay, so you find out that to get our greatest possible value, our y should be greater. Our y here should be greater. Then our x should be smaller. Okay, so the number that I can think of is y is 10 there. Okay, then my x should be a 0. Okay. If I have my x as a 0, I'll have a largest number. So it's going to be when my y is a 10 and my x is a 0 there. So I'll have y, which is 10, 10 squared minus 0 squared, I'll get 100, minus 0, I'll get 100. That's the greatest possible value that I can get of. Then the other question is now saying the least possible value of x times y. So we want the least. Okay, so for the least now, looking at my range there, the least possible value that I can think of, I should have greatest value of y. So the greatest value of y I can think of is a 10. So my y is still a 10. Then the greatest value for x that I can have is, the lowest value of x that I can have of is minus 2 there. Okay, so I'm going to have my x is minus 2. So when I say x times y, I'll have 10 minus 2 times a 10 there. I'm getting minus 20. Minus 20 is very, very big. Someone was going to think of x as a 0. When you think of x as a 0, then you get 0 times 10, you get a 0. 0 and minus 20, which one is greatest? 0 is bigger. This one is smaller. Okay, so that's the least possible value. Okay, let's move on to the next question. Okay, when we have such a question, you simply take first this one, then you take this one and that one like that. So let's do that. For the first one, I'll have 2x minus 6 is less or equal to 4x. Then the second one, I have 4x is less than 10 minus x. Now I solve these two equations. For the first one, I can take 2x this side and I'll have minus 6 is less or equal to 4x minus 2x. This becomes minus 6 is less or equal to 2x. I'll divide by 2. I'll divide by 2 there. They cancel here and here I get a minus 3. So my minus 3 is less or equal to x. The other one, I'll have 4x. I can take this one this side. So at the end of the day, it becomes 4x plus x is less than 10. This is 5x. 4x plus x, that's 5x is less than 10. I can divide by 5 by 5. Then my x is less than a 2. So writing now in the format that they've asked us, there you find out I can have my x at the center and then 2 is greater, so I have there 2 there and less or equal to minus 3 there. I have finished. Okay, so if they were going to ask us the value of a and the value of b there, your a is this one, your b is 2 there. Okay, let's move on to the next question. Represent the solution on a number line. So on a number line, we are saying this is our number line. I've got minus 3, minus 2, minus 1, 0, 1, 2, okay, like that. So this is x here. So someone can just skip all these numbers there and just have a 0 at the center. Now our minus x was has a shaded there, it's less or equal. So it's going to be shaded. This is shaded here. And then our 2, it's just a circle. So our solution is lying in there. Okay, like that. So we have drawn there. Now let's go to the next question. We've got v squared is equals to u squared plus 2as. This is now an equation from physics, this one. Okay. So they're saying make a the subject of formula. A the subject of formula. So I can say, first of all, I can take the u squared to this side. It becomes minus. So I have v squared minus u squared is equal to 2as. Now I have 2as. I can divide by 2 and s there to get my a. So what I divide on the left side, I also divide on the right side. Then you find out these two will cancel off each other. So our a is equal to v squared minus u squared over 2s, like that. That's the final thing. Then we are now asked, find A when we have S is equals to 5 and our U is 2 and our V is 2. So it's now a matter of substituting into our equation this one. So if you got that one wrong, then this one will also be a problem. Okay, so we are saying A is equal to V, that's a 2 squared, minus U, that's a 2 squared again, over our 2 times S, which is 5. So our A is equal to 2 squared, that's a 4, minus 2 squared, 4, over a 10. 4 minus 4, we have a 0 over a 10. So you find out at the end of the day, 0 divided by 10, we get a 0. So our acceleration there is 0 meters per second squared there. Okay. Let's move on. Then here we have got a joint variation. D varies jointly as S and T. So when we are to write this one, we can simply say our D varies jointly as S and T, like that. Then we introduce a constant, which I can say K there. So this is going to be D is equal to KST. Okay, we are done there. Let's move on to the next part. Find the value of K. Okay, so we are using this equation to find the value of K now. So we are saying D is 24. So we are saying D is 24. We can substitute D 24 is equal to K. S is 4 times our T is 2, like that. So 24 is equal to 4 times 2, that's 8K. We divide by 8 both sides, by 8 both sides, they cancel. So our 8 here is 3. So K is equal to a 3. We have found the value of K. Okay, now we are asked another question. Find the value of T. So for you to find the value of T, you have to write the relationship or a law or a formula that connects D, S, and T, and also includes our K. So we said our D is equal to 3ST. Okay, then we now substitute. Our D is 50. So that's 50 is equals to 3 times our S, that's a 10. Our T, we are looking for that. So this is going to be 50 is equals to 30T. To get our T, we divide by 30. We divide by 30. 30 cancels off each other. So here we are getting our answer 13 to 50, that's 1 and a 2 over 3. So our T is equal to 1 and 2 over a 3, like that. Okay, let's move on. Okay, now we have got a universal set. It has got this information. The first thing that we are given there is that number of universal set is 45. Okay, then number of A is 25. Okay, then we are also given N of A complement intersection B is 9. Okay, so when we have such an information, it's easier. Oh, they are asking us to draw a Venn diagram. Okay, fine. So our Venn diagram is going to look like this. We have our A, and there is an intersection part there. So I can have here an intersection, and I have my B there. Okay. Then in terms of the numbers there, for our A, we were told it has got 25. So I'm going to write 25 there, like that. Okay. Then we have got A, this part here, A complement intersection B. Basically what that means is this. We have got our Venn diagram, A and our B intersection, they are intersecting here, and our B there. So what it means when it's intersection, it means it's something that is in B, like that. Okay, something that is not in A but intersecting with what is in B. So you find out it's that information there. Okay, so this is basically representing this. Okay, So at the end of the day, I can write my 9 here, like that. Then we have the other part there, which is saying A, this part here, which is saying number of A intersection B is equal to the number of A union B, what is not in there. Basically, what this means is A in union B, when we combine A and B, what we don't have in those two. So when we draw this one, it's like this. Our A, our B. So it's everything that is outside outside A and B, basically. That's the information that we are talking about. Everything that is outside A and B. Okay, so now we are saying that one at the end of the day, if we have, now let's do this. When we have that, it means for our intersection, in this case, we can have, there's an intersection there, we can let it be X like that, okay? Then when it's X like that, for our A, I can say minus X because there's an intersection there, like that. Then we also have a certain number that is going to remain, because if we say our A 25 plus 9, there's a remainder there that is remaining, which is, we can also take that as an X there, which we have said is also the intersection. Now with this information, we can now, we can find the value of X there, okay? Or else this is also okay. If we want, we can leave it like this. But if we want to simplify our life, we can now say our 25 minus X plus the intersection X there plus 9 plus the X outside there is going to be equal to the total 45 there. Then we find the value of X. So if we combine this X plus this one, that's a 0, this one is going to be an X. So I have plus X here. 25 plus 9, that's 34 here, is equal to 45. So my X is equal to 45 minus 34. So my X value is equal to 11 there. So I can come here and substitute the values there and say, for this one, 11 outside, 11 at the center. Then for A, it was 25 minus 11. So it's going to be a 14 in here. So now I have finished everything there. So this is the Venn diagram there. Okay, let's move on to the next question. Find the number of terms in B. Number of terms in B are these ones. Everything that is in B. So it's going to be n of B is equal to 11 plus a 9. So we get a 20 there. Okay, so that's how we get that one. Let's move on. Okay, on this one, we have a function of x is equal to that, where our x is not equal to minus 2 there. Because when it's minus 2, then we have a 0. Then we have a number divided by a 0, which is undefined. So find f of minus 1. We are simply substituting. Where we have our x, we put minus 1. So it's going to be, this is equal to 3 over minus 1 plus a 2. So this is equal to 3 over minus 1 plus a 2. I will get myself a 1 here. Okay, so the answer is a 3. Let's move on to the next one. Okay, they are saying the value, find the value of x for which f of x is minus 3 over 4. So our f of x was 3 over x plus 2. So this is now equal to that there. So it's now equal to minus 3 over 4. So what we do here, we do cross multiplication here, like that. So it's going to be 3 times 4, okay, is equal to minus 3 by x plus 2 there. Okay, so this is a 12 is equal to minus 3x minus 6. Okay, so at this point, I can take either 3x here and then this one this side, so that I have a positive x value there. So it's going to be 3x here is equal to minus 6 minus 12. So this is a minus 18 there, and a 3x. I'll divide by 3 there. So my x is equal to minus 6. Okay, so that's the value of our x there. Let's move on to the next question. Okay, we are on question number 21 now. Number 21 is saying, the diagram above shows a speed time graph of a moving object. The object decelerates uniformly at 3 meters per second squared from a speed of v meters per second to a speed of 15 meters per second in 5 seconds. It maintains the speed of 15 meters per second for a further 5 seconds. It then decelerates uniformly until it comes to rest after 3 seconds. Calculate the value of v. Okay, so what I can do for this one, let me just zoom in a little bit. I can say at this point here, I've got my x value. Let me just reduce here. My x value is 0, and I have my x value, my y value is a v there, like that. Then another point here I can take is my x is a 5 there, and my y is my 15 there. Okay, so because I'm taking this as my y and this as my x. Okay, so if I do this, my gradient is going to be change in y over change in x. If you don't want to use the y and the x, you can use the velocity here, the speed, and the time. So you'll be like saying your change in speed over your change in time. It's one and the same thing. Okay, so let's finish that. So at the end of the day, we'll get, if we use either one of those, for the first one, we can say we have v, which is v. This is my v. This is my v2, my v1 there, initial v, and v2 there. So it's going to be v2, which is 15, this 15, minus v over, in terms of time, that's a 5 minus a 0. So I'm getting 15 minus v, because the gradient that I have, they told us that the deceleration was equal to 3 meters per second there. So we already have the value there. So this is equal to a 3 there over a 5. So 5 times 3, that's 15, is equals to 15 minus v. Okay, so my v, I can take it this side, and my this is a negative here because it's decelerating. So this is a negative there also. Okay, fine. I'm sorry about that, because when it's decelerating, it's a negative gradient. Okay, then this is going to be going this side, it becomes a positive. So our v is equals to 15 plus 15. So v is equals to 30 meters per second, like that. Okay, let's move on to the next question. The next question is asking us the deceleration in the last 3 seconds. Okay, so for the last 3 seconds, we can also do the same thing there, where we said our acceleration is equal to our change in speed over change in time. Okay, like that. So let's go and check the points. Let's look for the points now. Last 3 seconds. So we said here is 30. Let me just write here. We said it's 30 here, meters per second. Okay, so the last 3 seconds, you find out these are those ones. We are moving from 10 here to 13. So these are 3 seconds there. And at this point here, I've got my time is 10 and my speed is 15 here. And at this point, my time is 13 there, and my speed is now 0. So the acceleration is going to be equal to, if I take this as v1 and this as v2 there, it's going to be 0 minus 15 over 13 minus 10 there. So it's going to be minus 15 over a 3. So I'm getting a minus 5 meters per second there, second squared there, per second squared. Okay. So when I get a minus, basically, it's just showing me that it is deceleration. It is deceleration because we were talking about acceleration formula. And when we get it as minus 5 meters per second squared, it shows that it is deceleration. So you can say deceleration is equal to 5 meters per second there. You don't have to write the minus because the minus is counted for by the deceleration there. Okay. Now, the last question is saying the distance traveled in the last 8 seconds. So basically, when we have a speed time graph, when they say find the distance, it's basically area under the graph. Okay, last 8 seconds. 8 seconds, here we have 3 and here we've got 5. So it's going to be, the shape is this one. This one here to here and here. So we have a trapezium. If you want, you can divide it and have a rectangle, area A and area B there. So for area A, this is a 5, 10, and this is a 15 here, and this is a 13. Okay. So area of A is equal to length times width, which is 5 times 15 there. I will get 75 meters. Then plus area B. Area B is half base times height. So it's my half base is my 3 here times my height 15. So you find out when I do this one, I'll get 22.5. So I'll add these two together. 75 plus 22.5, we get 97. So our area, our distance is 97.5 meters. That's the distance traveled in the last 8 seconds. Okay, let's move on to the next question. By selling an article for $20, a dealer made a profit of 25%. Calculate the cost of the article. So you find out here the $20 there. By selling an article, it's like we are selling at $20. It's as to 25 plus 100. So it's 125%. We want to find the original price, which is 100%. So it's going to be a less here. So we can say when it's less, you say 100 over 125 times $20 there. Okay. So if I divide there, 5 into here, 4, 5 there, 5, remainder 250. 5 there, and I divide. So if I multiply 100 by 4 and divide by 55, I'm going to get $16 here. Okay, so that's the original price there. Let's move on to the next one. Given that we've got that, find the ratio of TS to 5. Basically, when we have a ratio of TS to 5, we want to find T over S. That's the simplest way of finding it. So let's now cross multiply. We cross multiply this one and we cross multiply like that. Okay, so let's do that. If we do that, we are going to get 3 times 7t minus s is equal to s minus 5t over, we are multiplying here again by a 2. Okay, so when I multiply there by a 2, I'm going to get 7 times 3, that's 21t, minus 3 times minus 5, that's minus 15 there. Okay, 3 times minus, oh, that's s, that's minus 3s. Okay, is equal to 2 by s, that's 2s here, minus 10t. Okay, So I want to have the t's on one side. So for this one, I can take my t, because I want to have t divided by that, like that. Okay. So if I take my t, let me take this one, this side. Okay, let me do that. I'll have 21t is equal to 2s, then this one becomes a plus 2s. So I have 31t is equal to 5s. And remember, we want to find in terms of t over s. So when I want to find t over s, I'm going to divide this side, I'll divide by 31. This side, I'll divide by 31. And I also divide by s here, divide by s here. So here, so that I remove the s here. Okay, and I'll have a t and a s like that. Okay, t and a s like this here. Okay, so at the end of the day, the 31s, they cancel off each other. So my t over s here is equal to 5 over 31. So the ratio we can now write in terms of ts to s is 5s to 31. Okay, let's move on. We are now given that the gradient, a straight line L passes through the origin and the point 1, 2. Okay, 1, 2. Is passing through, so let me just draw it. It's passing through the origin there. This is the origin. This is my y. This is my x. Then it's passing through a point 1, 2, like that. Okay, so this is my x value. This is my y value. And these ones, it's 0 and 0. Okay, so they're asking us to find the gradient of the line. Gradient of the line, gradient, basically, gradient is equal to change in y over change in x. So I can have this as my y1 and this as my y2 here. Okay, so I can say y1 minus y2, so it will be like 2 minus a 0 over 1 minus a 0. I'm going to get 2 over 1, that's a 2. So the gradient is equal to a 2. Okay, we are done with this question. Then the equation of the line L. Equation, basically, equation we write in the form of y is equals to mx plus a c. Okay, where our m is the gradient, this is the gradient, and our c is the y-intercept. Y-intercept is basically a point where the line cuts the x-axis. So you find out from our drawing there, it was cutting the x-axis at 0, 0. So our c is 0. So I can write the equation as y is equals to, our gradient is 2 and our x there. Okay, so this is the equation there. Let's move on. Oh, this is the last question there. Okay, thank you guys. Please remember to subscribe on our YouTube channel, Mobilemaths, and share with your colleagues. Okay, bye-bye.